All right, today we are moving on to section 6.2. We are going to use proportions to solve geometry problems. So for our warm-ups, we've got a few proportions. These ones do not involve any factoring or anything like that, so these should be pretty quick to solve. How do we solve proportions? Cross multiply. We take the cross product. Sometimes we could refer to that as the product of the means equal to the product of the extremes. So in this case, that would be 8 times 6 equals 3 times x plus 1. Remember to put parentheses around any numerators or denominators that have more than one term so that you remember to distribute. 48 equals 3x plus 3. To solve that, what do we need to do? Subtract 3, and then divide by 3. We should get x equals 15. Anybody get to number 2 and notice something about it? Kara? It's the same thing. Even from the beginning, if we take our cross products, we're still taking 8 times 6, or 6 times 8, and 3 times x plus 1. Now, even if you wrote the 6 and the 8 the other way, even if you put the 3x plus 1 on the left and 8 times 6 on the right, it's still the same thing. So, same thing. Same thing. Our answer would end up being 15 again. Okay, that problem's not any different. Looking at number 3, what do we notice? Same thing again. If you wanted to on this one, you could put the 3 times x plus 1 on the left and 6 times 8 on the right. But really, it's the same thing. You're still multiplying the same stuff together, setting the same stuff equal to each other, and you should have gotten x equals 15 again. If you wrote out all the work on each one, that's fine. Okay. Should have gotten x equals 15 every time. Questions about the warm-ups? All right, then let's move on. Properties of proportions. The cross product property we've already talked about. The product of the means equals the product of the extremes. So in this case, what are the means for this first proportion? Good. So b times c is equal to, what are my extremes? A times D. Okay, we've already talked about that one. The reciprocal property, if two ratios are equal, then their reciprocals are equal. What is the reciprocal of A over B? B over A. And the reciprocal of C over D? D over C. Notice that if we were to take our cross products again, B and C still end up getting multiplied. A and D still end up getting multiplied. Just like above, even if it happens in a different place. If you interchange the means of the proportion, you form another true proportion. So again, our means were B and C. So if we swap B and C, we'd have A over C and B over D. Once again, we'd be multiplying A and D together. We'd be multiplying B and C together, even if it happens in a different place. The last one is kind of the weirdest one of them all. If you add the value of each ratio's denominator to its numerator, then you form another true proportion. So, adding the denominator, so we've got to take A plus B over B. We didn't change the denominator. Would be equal to C plus D still over D. Now, if you want to, we can show the work how this ends up being the same thing. We would have to take D and distribute it to A plus B. Set that equal to B distributed to C plus D. When we do that, I'll jump below here. We'd have DA plus DB equal to BC plus BD. Oh, I didn't get that as low as I thought I did. Let me move this down a little bit. DA plus DB. Okay, that's slightly better. What's true about DB and BD? They're the same thing. So those could get crossed off because even though they're written backwards from each other, multiplication is commutative. We can do it in whatever order we want. So that means we're left with, can't find a good place to write it. We're left with DA equal to BC, which really DA and AD are the same thing. Notice that's what we had up here. We just swapped sides. So we can mathematically show that this would end up being the same as up here. Now, if you don't really care about that, no big deal. I mean, as long as you can memorize this, I guess that's fine. Questions about any of our properties? Concerns? Confusion? Need more time? All right, we'll keep it moving. In the diagram, AC to DF is equal to BC to EF. Write 4 true proportions. So we'll go ahead and use the numbers they gave us instead of using all the AC, DF, BC, EF. So let's start by just plugging in the numbers. What is AC? What is DF? Equals what is BC and EF? Okay. There's one. What's another one? So go through these properties. Atea? So that would be if we were trying to solve it, but that's not a proportion. So remember, a proportion is 2 ratios equal to each other. Kobe? 18 over 12 is equal to x over 9. The reciprocal property. We take the reciprocal of each. They're still equal. Okay? Atea? 12 over 9 is equal to 18 over x. I would agree. We swap the means. We get the same proportion. Last one's the trickiest one. Any new volunteers? Majay?
12 plus 18 over 18 is 9 plus x over 8.
Okay, so we add the denominator from the original one we did to the numerator. Equals 9 plus x over x. And that would give us another true one. Technically, we could write even more of them using that last property. We could do that for both of these also. So we could do 18 plus 12 over 12, x plus 9 over 9. But they said 4, we got 4. Questions about applying those properties to make multiple true proportions? Yes, ma'am. So this last one came from the last property in that box where it said that you could add the denominator to its numerator. So we used the original one and added the 18 to the 12. We added the x to the 9. Anything else? Don't throw things in my classroom. Okay. In the diagram, SV to VT is equal to SU to UR. Find ST and VT. In my opinion, the best way to start these is to take the proportion they give you and fill it in with numbers or variables or expressions from the diagram. So, SV has a length of. VT is a little tricky. Does anybody know how we could express VT? Kobe?
8.
Close. You're on the right track. John? Disagree. Maj? X minus 8. So if X is the whole thing, and we only want part of it, we just have to take away or subtract that 8. So X minus 8 is how we could express VT. Okay, now if you need to go all the way back to first semester segment addition, SV plus VT equals ST. Plug in everything they told you. 8 plus VT equals X. Subtract the 8. That's how we got VT is X minus 8. Questions about VT? Okay, that's the trickiest part of this. So we're moving on to the other one. What is SU? And UR? From there, I think you can all do this. Some of you have already started, maybe finished it. How would we solve this? Cross multiply. 8 times 28 equals 12 times X minus 8. What did we get for 8 times 28? 224. Distribute your 12. You get 12x minus 96. How do we keep solving it? Add 96 on both sides. That would give us 324 equals 12x. Last step. Divide by 12. Oh, 320, sorry. Divide by 12, what do we get?
26.
A decimal? 26.6 repeating? Is that what we got?
Yeah.
Okay. Equals X. Is that our answer? No, they wanted us to find ST and VT. So that's part of our answer. Which part is it? ST. They said ST is X. So ST is 26.6 repeating. I am not okay with you rounding that or dropping the 0.6 or making it 27. I would be okay with an improper fraction. So if you took 320 over 12 and just reduced it, I would be fine with that. Okay, but we need exact answers, not rounded answers. In order to get VT, what am I going to do? Subtract 8, and what do we get? 18.6 repeating. Questions, concerns? Need more time? Okay, we'll move on. We've got a similar problem with a different triangle. I'll give you a minute to try this one out on your own. Again, I would recommend starting with the proportion they gave you and plugging in numbers, variables, expressions from the diagram. Expressing JL is going to be similar to when we had to express VT on the last one. So JL is the only one that they did not give us directly. How did we express JL? Good, we should have expressed it as x minus 2 over LH 2 equals JK over KG. Okay. When we cross multiply, 5 times x minus 2 equals 30. What came next? Distribute. 5x minus 10 equals 30. To solve it, we need to add 5x equals, then x would equal 8. So that does not give us JH, which is what problem 1 wanted. JH is going to be 6. 6? No. Oh, that did give us JH, didn't it? Sorry. I was looking at the last one. So JH does equal 8. That makes sense that they would put that one first. So JL would be 6. JL 8 minus the 2 at the bottom, we get 6. No, you do not have to show the 8 minus 2. Everything up here I should see. Okay, you need to be showing your work. Questions, concerns about example 3? Need more time with it. All right. A scale drawing, you may have heard of these before, is a drawing that is the same shape as the object it represents. To find the scale of an object, write the ratio of a length in the drawing to an actual length. Then rewrite the ratio so that the denominator is 1. It is possible to use scales where the denominator is not a 1, but for the traditional method, you want a denominator of 1. Another thing I'll mention before we keep going is that you are going to want the drawing, or the model is sometimes what it's called. Model or drawing. Those values will be in your numerator. The actual values or real life values will go in a denominator. So in any type of problem like this, model or drawing goes on top, actual length goes on bottom. You might be familiar with using a scale on a map, if they still teach map reading. I think I always learned it in history classes or social studies classes in junior high. Anybody ever do a map reading with a scale? You have to figure out how far something actually is away. We just use Google Maps now, move on with our lives. Okay. Well, back in the day, when you actually had to be able to read a map, you had to be able to measure, and then in the bottom of the map, sometimes I think they still might show this on Google Maps, you'll see like these little bars down here, and it'll be labeled with like however long this is. This would be 1 mile. 1 mile. So if this were to measure like 1 inch, then every inch on the map represents 1 mile in real life. We seen that before? Okay. So that's an example of where you would see a scale drawing. Maps are a commonplace. All right, example 4. The length of a key in the scale drawing is 7 centimeters. The length of the actual key is 4 centimeters. What is the scale of the drawing? So, the model or drawing goes on top, 7 centimeters. The actual length goes on the bottom, 4 centimeters. We want to force this to have a denominator of 1. How am I going to take 4 and make it into a 1? Divide it by 4. But if we do that to the denominator, we should probably also do it to the numerator. Got to keep it fair. So we know we'll have a 1 on the bottom. 7 divided by 4, 1.75 centimeters. So 1.75 centimeters in the drawing represents 1 centimeter in real life. So did they make their picture bigger or smaller than the actual item? Bigger. That's a concept that's going to come back when we start that project. The project that's coming, I'll assign it on Monday. I think I've got it assigned on Monday. Then you're going to see taking a picture and making it bigger using a scale. Questions, concerns about example 4? All right. Example 5, a model of a Sherman tank has a scale of 1 to 16. Now you could change this and take 1 divided by 16, so that way you would have a denominator of 1. You don't really need to. So here, if we use our scale as a fraction instead, remember that the model number is always on top. The actual number is on bottom. So they're saying the length of the actual tank is 584 centimeters. What's the length of the model? Well, one way we could do this would be, yes, to take 1/16. The other way would be to set up a proportion. So I'm going to show the proportion way just so you get familiar with how to set these up if the numbers aren't always as easy to work with. So the 584 is the actual tank. Where should that go? On the bottom. If we are trying to find the length of the model, what should we put on top? An X. So when we cross multiply, 584 equals 16x. Divide. So yes, you're taking a 16th of it. What do you get for x? What are my units? Centimeters. Keep them the same. So the length of the model tank would be 36.5 centimeters. Letter B, they switch it up on us. This time they give us the width of the model. So in my opinion, the numbers aren't quite as easy this time around with the decimal. Where should that 16.375 go? On the top. Which means if I'm looking for the actual width, it would be an X on the bottom. It's the only place for it to go. This makes it easy. All you have to do is multiply. And what do we get for X? Wow, that was a lot of soft mumbling. Anybody loud and proud? There we go. 262 centimeters. The actual tank stands 9 feet tall. What is the height of the model in inches? So we can start this off the same way. I'm going to show my work for this off to the side since I'm out of room at the bottom. Again, we start off with our 1/16. Remember, they didn't put units up here. They didn't say this has to be centimeters, this has to be feet. So we can keep using that same scale ratio. We'll just have to worry about our units at the end. So if the actual tank is 9 feet tall, where should that 9 go? On the bottom, which means on top I have X. When we cross multiply, 16x equals 9. X equals... If you put it as a decimal right now and you write the whole thing out, that's fine. For the moment, I'm going to leave mine as feet, as a fraction. Okay. We're in feet. We don't want feet. We want inches. How do I take feet and make it into inches? Multiply by what? 12. There are 12 inches in a foot. So I'm going to take 9/16, multiply it by 12/1. Again, if you did this with a decimal and you wrote the whole thing out and you're multiplying the whole thing by 12, you should still get the correct answer. Do not round it if you're putting it into decimals. I like the idea of cross-canceling. So I end up with 27/4 inches. What do we get it as a decimal? 6.75. I would accept either one of those. Make sure you're labeling your units. Technically, I would also take 6 3/4. That's how you really want to write it. That's fine. Questions, concerns about what I expect to see, how I expect you to write your answer, why you should not be rounding. Nothing? Warm, fuzzy feelings all around? Okay.